I'm speaking to Chris Reed, professor in computer science and philosophy at the University of Dundee. So Chris, I find your area of expertise very interesting because you combine a very old field of research, actually, which is argumentational theory, with a very new field of research, which is artificial intelligence. Can you tell me a bit more about this?
Certainly. So I think that to understand human reasoning, we have to be able to combine not just argumentation theory and the study of human reasoning that philosophers have been working on for millennia, with artificial intelligence and the very newest models coming from advanced computer science, but also many other disciplines. And I think that it's somewhat inevitable because human reasoning is so ubiquitous. So I like to follow the words of the 20th century American philosopher Willard Van Orman Quine, who said that the divisions of the universe are not the same as the divisions of the university, so that we have to be able to cross these traditional disciplinary boundaries in order to be able to tackle the problem. And it's not even just thinking also about the language that we use when we argue, so thinking about the linguistics. It's not just thinking about the impact that it has on our cognitive models, so the cognitive science and psychology, but also about some kind of sensitivity to the domains in which we conduct our reasoning. So, and here you can think of anywhere, right? I mean, so the law courts, we need our models of jurisprudence and the process of legal undertakings in order to be able to understand reasoning there. If we're trying to figure out what should happen with some kind of public policy, then we need a sensitivity towards political science and what constitutes good democracy, and so on and so forth. Right? So wherever that we see human reasoning, then we need to have an academic understanding of the domain coupled with these models from psychology and linguistics and AI and so on. So I think essentially it's inevitable that the study of human reasoning and latterly computational AI models of human reasoning are inevitably so multidisciplinary.
Right, and you speak about these varieties of disciplines that you need to understand and have some sort of sensitivity towards to be able to make these models, actually. How difficult is it to actually teach a machine to reason in a certain discipline?
Okay, that's kind of interesting. So it's very much horses for courses, that it depends on the area, and some areas at least are a little bit easier to model and understand than others, although all present a huge amount of challenge, I must also say. So I guess if you look at something like, well, I mentioned the law courts, there are very tight rules on process. So there are only a certain number of things that anyone can do at a given point. And we know what those are a priori. So we can build our computational models with that information kind of guiding us and kind of constraining the complexity of the task. But in some of the work that we've been doing more recently, we've started to tackle much more demanding environments. And one of my favorites most recently was looking at mediators, and not just large-scale corporate mediators, but very small-scale couples mediation, right? Where you've got a husband and a wife who are obviously enormously invested in the process and the content of the discussion, and the mediator is there to try and facilitate some kind of resolution to a deep disagreement. And the language use and the subtlety and of course the emotional contour through the discourse is so demanding that trying to build computational models of that sort of interaction is hugely complicated. But I'm a firm believer of kind of trying to tackle those really tough problems, not in the hope necessarily of being able to solve them anytime soon, but rather as a way of understanding the domain as a whole. So understanding what the challenges are in looking at human reasoning. So I mean, actually, mediators are a good example of this one particular characteristic of what they do that's quite deep and quite interesting, that they talk about reframing. So the way that you take somebody's words and then shift them to present it to the other party. And this is very difficult for computational models to understand, and yet it's a defining feature of that kind of reasoning. But but it means that by trying to get some kind of understanding, some kind of computational model of what's going on there, where it's so important, we can then transfer that knowledge to other domains, because that same phenomenon of reframing happens all over the place.
Okay. And if you try to tackle something as complex as reframing, how do you get this sort of objective evaluation of how it's being done by humans to teach a computer how it should be done?
Right, so that's quite hard, and there's no kind of panacea here. That we have to be a little bit pragmatic. So the most usual approach right across computational linguistics and natural language processing is essentially to put many people on the task. So you put as many people as, frankly, your research project or your company can afford, looking at not different data sets, but looking at exactly the same data set. And then according to your kind of preconceived ideas of what you expect to find there, they all annotate, they all look at the data and say, well, I'm thinking that there's a reframing of this sort going on. And when you've got the 2 or 3 or 10 different views from humans, you can then measure between and get some kind of understanding of the agreement between the annotators. If that agreement is high, then you know that your theory is reasonably robust, and you can then build the machines that try to emulate that theory and then compare between humans and machines. Of course, if there's poor agreement between annotators, then you need to sort of think very carefully about whether or not it's time to go back to the theoretical drawing board.
And then it's still difficult for humans too.
Exactly. To be honest, actually, that's one of the challenges, that things like argumentation are active at such a high kind of level of pragmatics that in fact people do disagree a lot on what's actually going on in a discussion, in a way that they don't disagree when you say, is this a verb or a noun? And we still don't have good models that are robust to that kind of variation. We don't have the scientific methodology for dealing with that kind of shifting grounds at that level of human communication. So that's still a very significant open research problem.
And would you say that this is one of the open research problems in this field? Would you say it's the most difficult one to tackle for this area?
So I think, no, it's rather a methodological issue, and our methodology is evolving, as is our understanding of just how difficult a problem it is. I mean, if we kind of cut it down and think less about domain and just focus on the sort of, in some sense, simply defined problem of taking some kind of discourse, some text or transcript, and saying, okay, where are the arguments, where are the conclusions, where are the premises here? And we can set humans on this task, and if they're sufficiently trained, then they can do it fairly reliably. And then we give this task to machines, and they are more or less hopeless at it. Right? I mean, perhaps in particular domains with a lot of assumptions, we can get tolerable performance. But what's interesting is that the performance is nowhere near as good as other areas of NLP, of natural language processing. We don't see that same kind of robustness. And interestingly, we don't see the same kind of performance coming from deep learning models. Mm-hmm. So deep learning has been wildly successful in many areas of NLP over the last 5 years. And there was a kind of assumption, basically, that we'd be able to throw many of the same techniques at argument mining, this process of extracting the reasoning from text. And although there have been some modest sort of successes in some places, people have met a lot of very deep challenges. And we're starting to understand that that's not going to work, not on its own. We're going to need some other smarts in the mix to be able to solve that problem.
And what would you say is the main reason for that it is not working as you would expect it to work?
Well, so I think there are many things that are coming together. So one is that the kinds of phenomena that we're interested in are very complex. And that means that in order to get the amount of data that you need in order to be able to see enough examples of each kind of setup, right, is really difficult. It's much easier to get, enough examples of a noun phrase followed by a verb phrase than it is of this particular style of reasoning. And, we often have to seed our models with just single cases of each sort of example. And that's really hard. It's really hard to know how to to sort of build our models when we have such a paucity of data. So I think that's a big problem. But I think also there's the theoretical complexity, right? So we have reasonably robust models of syntactic arrangement, whereas our models of arrangement in argumentation are much more contentious. So there's a very large and active field in philosophy that is essentially talking about the ways in which people either do argue or should argue, and we don't have a coherent picture of what the right answer is, in the same way that we do for syntax, say.
So would you say that if the advances are made in the direction that you're describing, well, first maybe a better question is, do you expect it to be solved at some point in time?
Well, that's a good question. It's certainly the case that bits of the problem can be solved, right? So I think things like being able to identify the main point, being able to identify some of the key lines of reasoning, we should be able to do that. We're already starting to be able to do it in specific domains, and some of the techniques are now being brought up to a level of robustness that we can do it cross-domain. But the problem is that there's lots of subtlety in the way in which people present arguments, not least because they're often trying to be a little bit surreptitious, right? They're trying to sneak in a little bit of extra premise or lead you to a conclusion without actually saying it. So there's a lot of linguistic complexity. And I think that at the moment it's very much a case of just chipping away at various bits of the problem. I don't see any deep fundamental reason why we shouldn't be able to build large-scale robust models ultimately, but it's not as if it's just round the corner.
So would you say that if we had that ability to do it, that natural language processing as a field would really advance, and that applications like voice-controlled systems would work much better then as well?
I guess I'm biased, but solving this problem, being able to recognize large structures of human reasoning in text, it has got to be one of the most challenging problems in computational linguistics at the moment. So if we can solve it, then almost by definition, everything else is going to have come with it. With voice in particular, I'm not sure where the connection is. It's certainly the case that there's lots of prosodic and intonational clues that give us information about argument structure. And I would expect that there would be connections in the other direction, but I don't know how much it would buy you. That's all open research at the moment.
So Chris, in order to be able to create good models, you often have to have the availability of lots of training data. How do you acquire that in your field? Okay,
that is the $64,000 question. In fact, rather more. It's really hard and really essential. And ultimately, it's one of the reasons why argument mining as a field, the task of trying to recognize these structures, has essentially only gotten going very recently. Until about 5 years ago, there were maybe 2 or 3 papers in the field, and that's it. It was basically beyond the state of the art. And over the intervening few years, it has exploded like nothing else I've seen in over 20 years in academia. And part of that explosion, there are now 40 or 50 labs worldwide and hundreds of papers and several annual events and so on. It's a huge industry now. And I think one of the key things that has changed is that people have started to invest hugely. It's a significant investment in building the data sets of very carefully, closely annotated examples of argumentation and reasoning from different domains. So there are now these corpora of examples from internet fora, from student essays, US presidential debates, radio programs, and so on and so forth, right? And so you've got some monologue, some dialogue, you've got some collaborative, some competitive. So there are these different flavors, so we can start to see, these are robust corpora with good annotation agreement, and we can start to use them to seed all the various processes, whether it's statistical kind of machine learning type mechanisms, or whether it's rule-based or some kind of combination of the two. we're now getting a lot more kind of maturity in different teams being able to build on one another's results because of the availability of data. But it's basically that there is no magic solution. You just have to have a lot of people working for a long time on very close analysis. So I mentioned that we do some work with the BBC Department of Religion and Ethics and work with the Moral Maze programme. So it's a 45-minute programme with some absolutely fantastic debate going on. But it takes our analysts between 1 and 2 weeks to analyse those 45 minutes. It's a hugely labour-intensive task. But the fruits of that labour are then really quite remarkable. There's an enormous amount that we can learn from these data sets. And happily, so can other people. So there's now sharing of data sets and work on those data sets.
So if you've made these data sets and you've produced the models, how do you see that in the light of the GDPR discussions, the requirement to be able to explain why to come to a certain solution?
So that's interesting. I mean, I think that the legal push for being able to explain is coming at a kind of optimum moment in terms of the progress of the academic research, in that there's obviously a connection, and quite an intimate connection between argument and explanation. The structures seem to be very, very similar, and what changes is the linguistic contour and the intentions of the participants in discussion. So given that we're starting to build these increasingly robust models, maybe we can use those to be able to seed the processes of creating explanations. And I think that this is quite important because there's been quite a lot of assumption, I think, not everywhere, but from many quarters, that the systems that have to produce the solution, right, the answer to whatever question it might be, are the same systems as should be providing the explanations for that answer. And it doesn't seem to me that that's necessarily the case. I mean, it seems entirely reasonable that you have one system that comes up with, the answer 42, and then some other system that works in tandem with the first to try to then generate an explanation that makes sense for a human, or indeed for a particular human, for a particular audience.
You speak about the complexities of teaching a computer actually about argumentation, because argumentation is even difficult for humans sometimes to understand. And I was thinking that in addition to arguments, we also have the use of looking at someone's facial expression. We understand irony or sarcasm. How is that in this field? What's the relation?
Well, you're absolutely right that all of these things, and things like intonation, the prosody of how one communicates, these are hugely important in phrasing and in even framing whether or not something constitutes an argument. And I wish I had a better answer for you. But basically, these are just hugely difficult. And there have been some preliminary investigations of how to recognize these phenomena, how they play. But ultimately, it comes down rather prosaically to exactly the same problem that I was talking about previously in terms of the availability of data. So there are a small number of data sets in which you track, for example, and annotate for facial expressions and so on. But they're very few, and they're also very, very few for those also annotated for the argument structure. Right? You need the whole thing in concert. And at the moment, we simply don't have the mechanisms for being able to create large-scale data sets that characterize what's going on in interpersonal argumentation, combined with the facial stuff, the vocal stuff, gestural stuff. All of these are clearly important parts of argumentation and reasoning. But at the moment, they're just a little bit too far beyond where we're at for us to be able to build kind of coherent models across these different modalities. I think it'll come, but at the moment there's just a huge amount of practical challenge in collecting the data, managing the data, and then building the models on the basis of those data sets. So it's really tough.
Well, thank you very much for your time. It was very interesting to speak to you today.
It's been an absolute pleasure. Thank you.